Valence electrons are the electrons that are farthest from the nucleus. These are the electrons in the highest occupied shell. These electrons are chemically reactive. Looking at the electron configurations on table 2.3 from the text, we see that the highest shell for beryllium, for example, is 2, and there are 2 electrons in the 2s subshell. Thus, beryllium has 2 valence electrons. The highest shell for neon is also the second shell. However, neon has 2 electrons in the 2s subshell and 6 electrons in the 2p subshell. Thus, neon has 8 valence electrons. The highest shell for sulfur is 3. Since sulfur has 2 electrons in the 3s subshell and 4 electrons in the 3p subshell, sulfur has 6 valence electrons. You can always find valence electrons from an electron configuration. However, there is an easier way to determine the number of valence electrons in an atom. We will only need to know the valence electrons of main group elements, which are the elements in the S and the P blocks. To determine the number of valence electrons in a main group element, you merely count columns from left to right, ignoring the D block if the element is in the P block. For example, magnesium is in the second column and thus has 2 valence electrons. Any member of the alkaline earth metal family will have 2 valence electrons. Boron has 1, 2, 3 valence electrons, since it's in the third column, ignoring the D block. Any member of the boron family has 3 valence electrons. The only exception to this is helium. 1, 2, 3, 4, 5, 6, 7, 8. All of the noble gases have 8 valence electrons except helium. Helium only has 2 electrons, so it cannot have 8 valence electrons. The family number with the A in it also gives the number of valence electrons in a family, except for helium. For example, oxygen, sulfur, selenium, tellurium, and polonium are all in family 6A. These elements all have 6 valence electrons.